Hi, everybody. Let me wind the music down here. Welcome to Chemistry 161. Let me see here. I'm still doing some setup here real quick. I know people are still going to be filtering in here. It also looks like I have about 40 or so people watching right now, which is quite a bit, so we're going to go ahead and get started here. Oh, sorry, I'm complaining at my cat. My cat is right here. She wants to say hi, but she's also very far away. Let me do this. Oops, I'm on the wrong screen. All right, hopefully that my audio is not too loud. I guess we'll see. Okay, it works. Hi, again, welcome to Chem 161. I am your host or instructor or whatever, Wes Hillman. I have the privilege of being your instructor for the spring quarter term for Chem 161 at Everett Community College. Please go ahead and feel free to address me as any of the following. I mean, this is an online class, so just call me Professor Wes, or even just Wes. That's fine. That's going to be the handle that I have for handle. Who uses that term anymore? That's the username that I have for Discord, um, which we still need a Discord channel for. So we'll talk a little bit about that in a second. Um, I'm a huge nerd, as you probably could figure out from watching me play Donkey Kong Country 2 for you guys on Saturday. Not super well. I mean, up until the point that I had practiced, I did okay. So being a D&D and Shadowrun fan, any denomination of orc that you want to call me is fine. Professor Orc is fine. And then I had a student who called me boss, and I was like, oh, I'm definitely putting that on the list. So just don't call me Mr. Hillman. That's the one thing I'm not a big fan of. If you have a pixelated video, there should be, let me get the cursor. So like right here or so below where, oh, I can't point any further, but below right here, I guess it'd be further over. There should be a little gear icon, and click on that, and then pick as big of a number as you can. Like pick at least 720p. I stream in 1080p, so it should be pretty clear. What else do we have? Yeah, how do you contact me? There are a lot of you in Chem 161 this quarter because I'm teaching all 3 sections of it, and undoubtedly, many of you are going to have questions for me that you will want to have answered, but it won't be class time because once the class is over, this chat goes away. So how do you get a hold of me? So here's my email, whillman@everettcc.edu. Type that into your Google email and then just save it as an address or something, however Google bookmarks or does whatever these days. Just have that handy. You can also email me through Canvas. Canvas is a little slow with email. It doesn't send out email as fast as I'd like it to. But if you send it through just straight up Google and type that address directly into your to field, then I will get it probably a little quicker, like up to 10 minutes quicker or so. That's important if you're sending me an email late at night and you think I might have gone to bed. I do stay up rather late. I'm on a very forward shifted schedule, which means I go to bed around like 2 or 3 a.m. and I get up around like 10 or 11. Just because I teach night classes, so I mean, I might as well just be awake during the night classes. I mean, for your guys' sake, right? And again, if you need to contact me for any questions, email is the best way to do it, but also Discord. We do not have an official class Discord server yet. Ethically speaking, I cannot be the one to be in charge of the Discord because I should not be the one moderating your chat. So if any student wishes to set up a Discord channel for the class, send me an email with the invite link. Make sure that you make the invite link so that it does not expire. And then paste that into an email and send it to me, and then I'll put it on the class announcements, and then everybody will just join in. I will also join your Discord with your permission. A lot of students found it super useful last quarter to have me there. They could just ask me questions because literally my Discord window is just sits in the corner of my screen. I leave it open 24/7 so that everybody can message me whenever, and I check it constantly. Like, it even pings. You might even hear it ping if I forgot to put streamer mode on. Let me see if I did that. Yeah, I didn't put streamer mode on, so let me do that really quickly. Maya, please. Oh goodness. Okay, well, I have a cat, and she would like to say hello. Hold on. Maya, say hi. Say hi. Say hi. There you go. This is what I'm listening to in the background while I'm trying to talk to you guys. Is just meow, meow, meow. So, if you hear me complaining, it's because of my cat. But yeah, please, if somebody would set up a Discord server, I only need one, so I will just take the first one that I get. If multiple people do it, then I will just reply with, hey, we already have a server set up. Thank you. All right, so this is Chemistry 161, which means that presumably, one, you have taken Chem 140, which all of our Chem 140 classes use Canvas, or you have this is not your first class that you've taken here, and you are proficient with how Canvas works at the very least. You know how to get in there. And I actually don't know how you would find the link to this lecture without that. So just a brief overview of what our Canvas page looks like. Let me do that really quick. Oops, it's not the window I wanted that to go in. Maya's so sad. Wow, that's totally useless. Hold on. There we go. I'm going to cover the chat for a little bit here. There we go. Watch this not log me in because Canvas. Invalid username. I'm not going to change anything. That's Canvas. So, if you were concerned that Canvas is a buggy piece of shit, then you're not wrong. But unfortunately, it's our buggy piece of shit, and so we'll deal with it. Your screen should look something like this. Probably not with as many Chem 161s in there. I'm teaching, again, 3 sections of this, so you're going to be in either LSA, LSB, or LSC. I control them all by using a blueprint course, which just pastes everything automatically into those 3 courses. So they should all be identical. I'm just going to click on one of them for now. So this is LSA. There is a class section number at the top of this. That will be useful for you when we talk about labs and stuff, because it's going to ask you, hey, what section are you in? And you're going to need to designate that in some way so I don't get confused, because there are 90 of you, 90. And I need to organize all of my students in some manner. But more on that later. Just I'm highlighting it so you know where it is. On the Canvas page, you should be able to see these tabs. You should not be able to see anything past files. So, or including files, I guess. I can see those because I'm an administrator of the Canvas page. But all these pages are worthless to you anyway, so that's fine. So, on the announcements page, you're going to see a bunch of announcements by this picture with a U in it, because that's the picture it pastes for me when I upload from the blueprint. All of the announcements for the class are there, but they are also sent to your email. If you do not have email announcements set up, please make sure to do that. You do that by going through the Canvas settings. If you ask me a question and I have answered it in an announcement, I will just reply with, check the announcements, it's there. So that's where that is. The most important tab is probably this modules tab. Everybody has probably already gone here because you need to go there to access this link here. You can't actually see the lecture archive. Now you can. This link right here will be the link to the playlist for all of our lecture videos. So you can just click on this, and it should take you straight to this page, which there is only a Donkey Kong video in. But at the end of today, Today's lecture will appear right here in this list. What else do we have here in the modules tab that I care about? We'll talk about labs later. I'm going to refer back to this a little bit later when we're talking about the syllabus. Scrolling down, there are materials for each chapter that we are going to cover. We are going to cover chapters 1 through 6. Not in order, though. We do 1, 2, and then 6 comes after that, and then we do 3, 4, 5. So they are in the order of what we do them. And then don't worry about all this. This is just old stuff that I used for in-person, but doesn't really do me any good on online stuff. So in each module, there is a link to the recommended reading. So these all link to our textbook, and that looks like this. So I'm going to link directly there. So this is the OpenStax textbook. And of course, I'm getting advertisements on it. The table of contents over here, we're doing chapters 1 through 6, so we will cover all of these sections, and there are practice exercises in each chapter, which I have also linked in the module where it says recommended homework exercises. There we go, right here. I do not specify which problems you should do in a chapter. As you'll see, the homework is not graded. I recommend that you do as many problems as possible from the end of the... I don't know why. It might be because I'm in a browser. Oh, it's still here. Interesting. I'm going to have to look at that. I recommend that you do as many problems as possible from each section. So like we're going to talk about section 1.1 first, which is just like, what is chemistry? And answer all of these questions. And if you're proficient with that, then you're all set. That's not modules. There we go. Just checking to see if there's anything else. I think that's it. Cool. Okay. The next tab that we have is assignments. Assignments and quizzes are more or less the same thing. As I populate this with assignments, you will see new things appear here. I do have to click a button to make an assignment appear. So if I hit this button, chapter 1 quiz will be available, and if I hit it again, it'll go away. You'll also get emails over and over every time I hit the button, so I'm not going to do that. I found that out last period. Someone was like, hey, I just got 8 emails. And I was like, oh, have some more, and I went click, 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 click. And much fun was had by all. And then laboratory stuff down here. Those will again populate as the quarter progresses and we talk about assignments. So right now, the only thing that should be in your assignments tab is the orientation quiz, which everybody needs to complete to have access to everything else. Make sure you do the orientation quiz. You do need 100%. I know some students have emailed me asking, hey, it says I got everything right, but it's still not unlocked. What's going on? Double check to make sure you've answered the questions entirely. If it's a multiple choice question or multiple answer, where you have to check all the boxes that apply, and you don't check all the boxes that apply, but you don't check any wrong boxes, it'll just mark the ones that are correct as correct, and then tell you no other information. So if your modules are not open, that could be why. It will also tell you how many points you got for that problem. So if you see 0 out of 0.1, like, scour the syllabus for that specific question. Again, quiz is the same thing. Discussions, let's face it, nobody uses discussion boards on Canvas unless you are required to. Like, people use Discord and other live services. So that's why I have the class Discord available. So I will answer questions if they're posted to the discussion board, but I don't expect that this will get much use. And then finally, the grades button over here is how you check your current grade in the class. If I click on that, I'll commit a FERPA violation, so I'm not going to do that. And then these library links are provided just in case you need to access the library for any reason. Actually, before I go back to the slides here, the first thing we're going to access is this. This is the syllabus. So if you click on this, it'll open it in a screen right here, but if you have a slow internet connection or Canvas is idling or whatever, you can just download any file that is linked here by clicking on it up here. I already have that file open, so I'm going to close this window and then open this window, which of course isn't formatted correctly. And then I'll do this. All right. So I'd cover up your chat, what you see, but I can still see the chat, so. Let's talk about what exactly you have gotten yourselves into. All right. So for this class, strongly recommend that you meet the prerequisites. I am not going to enforce prerequisites because I don't have a wait list. But if you are not eligible for Pre-Calculus 1, then we may have issue with some of the math that is going on primarily in 162. If you're taking 141 right now, then you're all set. If you have completed, I want to say it's 96, then you're all set. If you're currently enrolled in 96 and you somehow got into this class, I would strongly recommend that you finish 96 first. But as long as you don't have too many credits, you might be okay. There's not a ton of math in this class. We start off doing a bit of math, and then at like week 4.5 or week 5 or so, we put the calculator down and we never touch it again. And it becomes an entirely conceptual class. I think somebody last quarter called it, holy shit, when did we start chemistry crazy? Like, the class just transforms and becomes something completely unique. That's when we start quantum mechanics. So, just a heads up that is a thing that will be coming. Presumably, you've also completed Chem 140 or have taken chemistry at the high school level, or you've completed Calculus 2 with a B+. The Calculus requirement is only just like, hey, if you have this level of math proficiency, you're probably okay to take this class. And then finally, English 101, because there's going to be a lot of reading. It's an online class. You're going to be reading a lot of documentation. You're going to be reading a lot of slides. You're going to be reading a lot of everything. And you also need to be able to communicate that information with me. So please make sure that you meet these requirements. And if you don't, recommend that you go back and do them. You still have to go back and finish these classes anyway at some point. As far as other things that are required for this class, obviously you need to have internet access. If you didn't, you would not be watching this right now. But you also need to have reliable data plans and or connectivity so that you don't completely run out of data at mid-quarter or mid-month or whatever. I do stream in 1080p. You can stream these videos in 240p if your connection is bad, but you will use a substantial amount of data if you are using like your phone or a mobile device or something like that to download the streams from YouTube through your provider. Strongly recommend that you use just have like an internet connection, so cable, fiber optic, whatever, some sort of broadband that has unlimited data so that you have full access to all the course videos whenever you need to. I will expect that you have such a method of access from this point forward. So if you email me on the day of exam number 1 saying, oh, I don't have internet, I'm going to shrug and say, I'm sorry, there's nothing I can do. Your exam is still due tonight. So please just make sure that you have a stable form of internet that you can use for this course, because you will need it. It is an online course. If you need materials such as like a laptop for ease of access, or maybe a hotspot to access for Wi-Fi, the college does have those materials available. You can contact the library at circulation@everettcc.edu. You can contact the help desk at everettcc.edu. And they will be able to point you in the right direction to acquiring these materials that you may need. Insofar as textbooks and such are concerned, the text that we're using is that online text that I showed you. the OpenStax Chemistry Atoms First book. Make sure if you are looking around on OpenStax that you are specifically using the Atoms First textbook and not just the chemistry textbook. The difference is that the chapters are done in a different order, and so my chapter 6 will not be the same as their chapter 6 if you're using the wrong version of the chemistry text. The link is provided right there. You can just go straight to the table of contents through that, or access through Canvas like I showed you. Another thing you're going to need is a calculator. Let me copy this link real quick. And then we'll paste it in here. This is a calculator that you can use online. It's called Wolfram Alpha. Wolfram Alpha is probably one of the best online calculators that I can think of. Let me get it on the screen here. There it is. So you can type in whatever you want to calculate here. So for example, if you had something like this, and like you had a system of equations, I don't know, something like that, and you're like, please solve this, and it will go, boop, there you go. This is where these lines intersect. Or maybe you have something like, I want to know what e to the 0.323 over pi times 1.8. There you go. It'll just spit that out for you. So if you have a calculator that is like a TI-30 or TI-83 or something like that, any calculator that can use the functions log, natural log, e, 10 to the, things like that. We're going to use all of those functions in 161, 162, 163. Please use that. Otherwise, you can use Wolfram Alpha. Have it bookmarked so that you can use it during a quiz or an exam. Yeah, I'm totally going to recommend the Lentech calculator too when we do molar mass. Lentech is super awesome. I don't put that in my syllabus. Maybe I should, actually. The other recommendation that I have is p-table, because it is a fancy periodic table. So let me find that here. Let me resize that. There we go. So there's p-table. It has all this information here that you can just kind of click around and play with. Like we can learn about cadmium or something. I don't know. Cadmium is toxic. Don't eat it. But it makes really, really bright red paints and pigments. So that's cool. So yeah, all of that information will be useful to you at various points throughout the quarter. So it is very much in your interest to have that information accessible in like a bookmark folder or whatever, because we'll be referring back to it constantly. All right. On the screen is the schedule. You've probably already noticed that we didn't have class yesterday, even though the syllabus and the course catalog say, hey, doesn't this class meet Monday, Tuesday, Wednesday? So I only meet 2 days a week. I used to do 3 days a week because the third day would be like a Q&A session and or a lab discussion. And what would end up happening is we would talk about the lab for 5 minutes because most of the labs are straightforward, and I write pages upon pages of documentation so that you can understand them anyway. And then nobody would have any questions, and then we would go. So I would block out 2 hours of my day and use 20 minutes of it. And nobody had questions, so it'd be like, okay, well, you don't have to sit here for an hour and a half. So I no longer do that. I now reserve the third day for issues. We'll call them issues with the schedule. So for instance, Memorial Day doesn't really apply to us. Memorial Day is on a Monday. But if I had a Monday class, then I would move that class to, say, Tuesday, and Monday would be the day off. During certain weeks, we will have review sessions right before an exam. That means that our lectures will be Monday and Tuesday instead of Tuesday and Wednesday, and then Wednesday will be the review session. Just because it doesn't really make much sense to have the review session and then 2 lectures and then the exam. So you'll see that on the calendar below. But on a week where we have a Monday lecture, things will get shuffled around. You'll get an announcement about it. It's also in the calendar at the bottom of this document. So refer to that if you aren't sure. Just keep that calendar handy. I know most people may not have printers at home. I don't have a printer that works anymore. But if you do, and you can print that document, just like tack it to your wall, that'd be a recommendation. What else do we have here? You are already in the stream. This is just etiquette rules. Like, don't be douchebags and you'll be fine. I will ban people that are derogatory to other people or appear to be spam bots. I have had to do that in the past. It's very easy. All I do is just click a button and then ban. Well, I can't ban myself, I guess, but... let's see here. Attendance is not required. This is an online course, so I encourage you to come to these lectures. And in fact, it looks like... How many people are here still? About 45. So about half of the people that have enrolled are here for the first lecture, which is about what I expected. If you can make the lectures, that's great. You can use the chat feature to ask me questions, and I feel like that's useful. Otherwise, don't feel obligated to show up if you absolutely can't, or if you're tired, or like you have too many things to do. These videos are all archived to YouTube. You can access them from the playlist at any time that you need to. I don't delete them at the end of the quarter. They will stay there forever until YouTube either deletes them for me or civilization collapses, basically. Like, those are the only things that will get my lectures taken off of the internet. I have no plans to remove them. So you can access them whenever, wherever you want. For homework, there is no assigned homework in this class because this is a college class. I will give you the link to the recommended exercises, and I will basically say, again, do as many as you can. There are answers to the odd-numbered problems in the textbook. That does not mean you should only do the odd-numbered problems. You should also attempt the even-numbered problems. The more practice you do, the more proficient you get. If you aren't sure about answers, that's what the Discord channel is for. You can always post a question in there and ask, hey, did you get this answer for this question? I don't police or monitor the Discord chat. It is for your use in any manner that you choose. You can also email me. I'm happy to answer any questions because I can do every problem in the textbook because I'm the instructor. I teach this stuff. So if you have a particularly challenging problem, and you're like, I just can't wrap my head around this, then send it to me and I'll see what I can do. For assessments that are graded, we're going to start with the lowest stakes thing, which is quizzes. Quizzes are, generally speaking, the hardest part of the class, which seems kind of weird because I just said it was the lowest stakes. But it is also the first time you are assessed. When you get to exams in the final, you pretty much already know the types of content and questions you'll be quizzed on. Here is how all assessment works for this class. So all of the assessment you're going to take online, quizzes, exams, final, operate in the same manner. So when we get to those, it'll be more or less, oh, you just do the same as quizzes. Every assessment is cumulative. What that means is that anything from previous chapters or previous quizzes or whatever is fair game. That said, I do focus on whatever the emphasis is. So, for example, there will be a quiz on Chapter 1, and it will emphasize Chapter 1, and you'll need to know all of the stuff in Chapter 1 for that. Chapter 2 will rely on content from Chapter 1, but I won't test you specifically on it. So, for instance, when we learn sig figs in Chapter 1, you don't get to flush that knowledge out of your brain and never use it again in Chapter 2 and 6, where it will be expected. The types of questions that you will see are multiple choice, fill in the blank, free response, categorization, all sorts of stuff. I've used mostly every type of question that I can. However, the questions will only appear one at a time, and the order that they appear is randomized. That means that your first question will not match anybody else's in the class to a very high degree of probability, because your question number 1 may be somebody else's question number 7, but within those pools of questions, your question number 1 comes from a pool of about 5 or 6 different options, and their question number 7 comes from the same pool of 5 or 6 options. So the odds of you getting the same question in the same position are very, 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 very small. Now, what that means is that it becomes very difficult to look up questions online. You can go ahead and try. Like if you want to go look up stuff on Chegg or Bartleby or whatever, I'm not going to stop you because one, I've tried to find my own questions and I haven't had much luck, and I have an Access account, so. And two, I restrict you in other ways. So the rules for taking quizzes online in my class and the exams and the final are you get any resource you want other than me. You can use your notes, you can use the internet, you can use your text, you can use other people, you cannot use me. If you ask me a question, I'll say, I can't answer this, it's the final, or I can't answer this, there's an exam going on. That's all. That's the only restriction. You can use any other restriction or any other stuff that you have access to. The trade-off is that if you are referring to information from other sources and those sources are not your brain, you're going to time out on my quizzes because the time limit for quizzes is roughly 35 minutes. 30 minutes for the first one, and then they get slightly longer because you have to do calculations. If you go looking for the answers, or if you go poking around Discord asking people, like, hey, this is my quiz question, can you answer it? They're not going to reply to you instantly. That's going to take like maybe a minute or two for somebody to get to you, if somebody answers your question at all, and your quiz timer is ticking down while that's going. So while I will not police the chat, and you can ask each other questions about anything you want, I will strongly recommend that the best way to become proficient and pass the quizzes in this class is to understand the material on your own. And then also keep in mind that your questions are not the same as other people's. So if you like print screen a question and then send it to somebody over private chat or whatever, they may never see that question. So you might not be helping them. And you only get to take the quiz once or twice anyway. So you won't get to see all of the iterations of the questions. Speaking of how many times you get to take the quiz, I allow you to take a quiz twice. You can take the exams twice. You can take the final twice. Everything online you can do 2 times. The reason that you can do this 2 times is because technical failure and system issues are a thing. I have had my cat step on my computer power switch while I was doing stuff, and then the computer just goes boop and it's off and everything is gone. If it can happen to me, it can happen to you guys, so I expect that. If you have a power failure, the server goes down and you can't access the quiz while you were quizzing or whatever, you get a second attempt. So you can always try again once things have improved, or you've put your cat in the other room or whatever. The caveat to that is, again, I'm giving you 2 attempts. You do not get any extra attempts for any reason. That said, the number of times that students have emailed me of, hey, I did it twice, but something came up both times. Can I have a third attempt? I've had 0 students in an entire year of having this policy implemented ask me for a third attempt. So 2 should be good. 1, I can totally understand not being enough. Now, if you take the assessment and you're like, I feel like I did really good, you do not need to take the second assessment. Your score is the higher of the 2 scores on your 2 attempts. So if your second attempt is blank, it's just recorded as 0. That will not be the higher of your 2 scores. We will use your first score. If you do poorly on the first attempt, take the exam again. That's totally valid. You can do that. The questions, again, will be randomized. You will not get the same test. They will not be in the same order. But it will be similar to the other test that you took, and so you could use that time between your first attempt and your second attempt to, say, study or brush up on things or ask questions or whatever. Quizzes are automatically graded, yes. Everything should auto-grade. However, your score and the answer key do not get revealed until I have all of the students' assessments in. So there are 90 of you, which means that on exam day, it may take a second for me to post exam scores. Because I have to hit a button. And when I hit that button, everybody's scores will appear. And then I have to hit a second button, and all the answers appear. So with quizzes and stuff, like, please message me or email me if something is like not appearing and you expect it to. Like, where's the answer key to the quizzes? Oh, Wes is a bonehead. He didn't hit a button. Like, let me know. I will fix those things right away. With exams, the only difference between exams and the quizzes is you never get to see the exam answer key. I know a lot of people would be like, well, if we had the exam answer key, we could study more effectively from it. Exams are not for your purposes of studying. Exams are for me to see how well you're doing in this class. That is it. The quizzes I encourage you to study from, but the exams you do not get to study from my exams. End of story. I realize other instructors may be different about that. You do not get your exam back. I give you your score, and that's it. It's kind of like the SAT. You send the SAT off, and they don't send you it back so that you can study for it. That's it. You never see that exam again. You just get a score. Same with the final exam. The only difference between the exams and the quizzes is that time is much more generous in some ways and a lot more constrained in others. So you get 75 minutes for an exam at least, and you get 2 hours for the final, but you do have more content. So make sure that you are staying on top of this stuff, and you should be in good shape. All right, so if you pasted a link for the Discord server into the chat, I don't see it because it will ban, it auto filters anything that looks like a link. Send me an email, and then what I can do is I can paste the link into the chat here. Is there a study guide for the exams or the finals? I don't know if I have study guides on the modules. Let me see. Do I have study guides? It differs per class. So for this class, it looks like I don't because I have all of the slides available for you to look at. So those are your study guides. But if you have specific questions, like what should we focus on? At the end of like the review session, we can actually just write out a study guide. So during the review day, if you have questions like, what do you think will be on the exam? I'll just ask you like, okay, what did we study in chapter 2? Do you think I could write an exam question on? And I'll have you list out the topics and then we'll make a study guide that way. So we'll do that on the review day. On the screen is the lab schedule. This is a laboratory class, even though it is online, but there will be no in-person lab content. You do not need to report to the college for any reason. Even if you did report to the college, they wouldn't let you in. There will be 5 lab assignments, and I will give you more information on those later on in the quarter, but I do want to return quickly to the modules tab to just talk about what the labs entail really briefly. So let me get... Let's see, is this the right screen? Yeah, there we go. First and foremost, for every lab, there are 2 documents. Some of them have a link to a playlist on YouTube, which is videos for that lab. The first document is the worksheet, which is just a PDF of all of the information that you will need to do the assignment. So there are descriptions of the assignment, descriptions of the equipment that would be used if you were doing the assignment, and then other questions that you're going to have to fill in information. Now, obviously, you can't write into this table because it's a PDF. So that's where this second document comes in. And that's right here. There we go. So these documents are Google Sheets, and you will be filling out these Google Sheets to answer laboratory questions. Then you'll download the worksheet and send it to me by uploading it into Canvas. The directions on how to do that are in a document that I'll show you in a second. You'll notice that this is set to read-only. You don't have to do that. I will get that during the break. Actually, if I have it... Oh, I haven't gotten it yet. I'm refreshing my email. Let me see if it shows up here. This might be it. Yeah, here we go. There you go. That's the class Discord. Now you can all join the Discord and chat without me because I'm giving a lecture. I'll have to join it during the break. The laboratory assignments are read-only, which means that you need to download your own copy. The way that you do that is discussed in the documentation, but You do that right here. You just click on Make a Copy. This will add it to your own Google Drive. You will need to be logged into some sort of Google account in order to do that. Your student email is a Google account, so use that if you need to. And then you can type everything that you want to. You can download the file and then upload it. I do have some specific requirements for labs. Rule number 1, you must use Google Sheets. The reason for that is because when you download that as an XLSX file from Google, I can read it in my ancient copy of Excel 2003. I kid you not. That's what I'm using. If you use a more modern version of Excel or OpenOffice or something like that and then send me that file, I will not be able to open it. You will not get credit. Please use Google Sheets. This is what works. This is what I have to use. Bear with me, okay? I prefer Excel over Google Sheets myself, but for this course, just make sure you're doing everything in Google Sheets. If you need information on how to get all of that, there is a document right here called How to Upload Worksheets to Canvas. It walks you through every step with pictures. Make sure that you are following this carefully, and you should be good to go. And you can always ask me any questions if you have them. What else do we have? So for my late policy, I need to explain the late policy first, and then I'm going to draw a picture because everybody refers to the picture, and a lot of people get confused by my late policy. So there are 2 deadlines for every assignment. Oh, let me answer this question real quick. Do you turn in any paperwork with your exams or quizzes? No, everything will be on Canvas. There's no partial credit in terms of showing your work or anything like that in this class because I don't have an equitable means of doing that. So if I say photograph your work and upload it to the server, I can't assume that everybody can do that easily. Does everybody have a smartphone? Probably. But is that a guarantee that I can make for 90 people and a requirement that I can implement? Not so easy. And I have to make sure that I do something that everybody has access to. Obviously, with an online class, if I'm labeling it as online, then you have to have internet in order to access it and sign up for it. So that stipulation is okay, but I can't really go much beyond that. So I've sort of tried to make a setup where everybody can access the stuff using things that are online and are free. Because it's for equity. Like, I can't assume that everybody has access to everything. Late policy. So everything has 2 deadlines. The first deadline is going to be the due date. When I assign something, it will put a due date on your Canvas calendar, and you will see that day as, oh, this assignment is coming up. Then what I do is I set a second deadline, which is the close date. The close date is the next day. What that means is that on the due date, your assignment is expected, and then after the due date passes, you have 24 hours to turn in your assignment, or else it receives no credit. Canvas will mark things late, but I ignore anything that says late. I don't care. As long as I get it, you get full credit for it. Okay? Now, if I draw that out as a picture here, then basically that works like this. So here's the analogy. Here's also the cat. Maya, I'm busy. So let's suppose that quiz number 1 is due, I don't know, the 15th. And then here's our calendar here. And I've already kind of screwed this up here. Let me try. There you go. So here's our calendar. So on the 15th, the assignment is due. So this is what is known as the soft deadline. And so Canvas will tell you, please turn in your assignment by midnight on the, or 11:59 p.m. on this day. The next day is the hard deadline, which is the close date. And what that means is that at midnight on the end of this day, the assignment closes. It disappears from Canvas. You can no longer upload or submit things, and whatever score is input in the system is then printed to the gradebook. So in other words, you're going to have a date on the calendar, but you can turn in stuff up to 1 day late. So if you turn in an assignment in this time frame, you're good. You'll get credit for it. Canvas will say late here, but don't worry about that. Nobody cares if it's late. I certainly don't. I'm going to grade it afterwards anyway. And this is an online class, so I want to give you a little bit of flexibility. If you turn in something over here, you get a 0. I assume that if you don't turn in something by the hard deadline, you didn't intend to turn it in at all. If you turn it in 5 minutes past the deadline, sorry. I have 2 notifications for this reason. So just be mindful of of how the calendar works, and make sure that you get your assignment in by the deadline. And if you miss that deadline, you still have 1 extra day to do it before the assignment closes. Again, this is sort of with the 2 quiz attempts thing. I give 2 deadlines because I was just constantly getting people asking me, can I get 1 more day? And so I was like, okay, I'll give everybody 1 more day. Why not? And then all of the problems went away. Almost all of them, anyway. There is one exception to that. We'll talk about that in the NQA policy. But for the most part, I strictly adhere to this. And if you send me an email like, please, 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 can I get more time? I'll say, you'll have to use your NQA, which is why I'm bringing that up. And if you miss 5 things in this class, or you miss the final exam, I cannot give you a passing score. So any assignment that is blank in my gradebook, and you have not emailed me to tell me, like, oh, I'm going to miss this, or I need an extension, I'll use my NQA, that sort of thing. If I have 5 blanks in my gradebook, I have to give you a V or an E. Or sorry, not E, F grade. I do allow you 1 oops in the quarter. If you have 1 thing that slips your mind and the deadline passes, what you can do is you can email me with NQA and just say, hey, I need this to be extended. Email me before any deadline, and I will extend it all the way through the end of the quarter for any 1 assignment of your choosing that is not an exam or a final. So you cannot extend the final because the final is the last day of the quarter. And if you extend exams, then I have to hold exam scores back until you're done, and I can't do that. So those are the 2 exceptions. You cannot use the NQA policy on an exam or a final. But any quiz or whatever, any lab assignment, if you miss it or you don't have enough time or just too much going on in your other classes, let me know. Just say, hey, I want to NQA this one. I'll turn it in when I can, and then that's fine. Your due date becomes the last day of the quarter. If you have an emergency, email me. I can work with you with emergencies. Emergencies would constitute things like, oh, I cannot take the exam on this day because, I don't know. The emergency I'm using this quarter is, oh, COVID appointments are available for the vaccine, and I already had an appointment on this day. Like, I'm getting my 2nd shot on, I want to say, the 25th or something like that. If there was an exam that day, I would tell the instructor, hey, I'm getting my shot. Sorry. And any instructor who told you you need to take the exam instead of getting vaccinated is a douche and should seriously consider their commitment to their job. That's my professional opinion. You should absolutely get vaccinated instead of taking my exam. I can make the exam on a different day for you. But in order for me to do that, I need to know. So if something happens, email me immediately, as soon as possible, and keep me on top of what's going on so that I can accommodate you. If you email me after the fact, I have to be a lot less lenient, okay? So, like, if you email me 3 days later saying, I missed the exam because I had a COVID vaccination appointment, I'll be like, why didn't you email me? Like, that's something that you could do, okay? So keep me on top of things so that I know what's going on, so that I'm not surprised. Because if you surprise me with stuff and it's past the deadline, there's a lot less that I can do. On the screen are how many points are in the class. There are 5 quizzes that are 25 points each, 2 exams for 75 points each, 5 labs for 25 points each, and then a final for 150. Total score is 550. You can calculate your grade by counting the number of points that you have been given so far in the quarter, and then putting your score in the appropriate bin. So everybody's going to have an F for a very long time until somebody gets 330 points. I mean, that's not really how grades work, but more or less, like, the only points that matter are how many you have at the end, right? So if you have 6 out of 10 points right now, doesn't matter. You could get all the remaining points and have 546 at the end and get an A, even though 6 out of 10 would put you right here, right? So don't worry about grades at the start. If you feel like you're falling behind at the start, grades tend to improve as the quarter goes on and as more points are added. So, but do feel free to ask me any questions about your grade if you have them, because I have a gradebook. Canvas has a gradebook. They often don't match, unfortunately. I grade you from my gradebook because my gradebook can deal with rounding and stuff, and Canvas doesn't know how to do extra credit in a lot of circumstances, and I have to do these weird workarounds, and it tends to break the system. So if you have questions, just ask about your grade. There is no extra credit other than on exams and in the final. I make the exams out of more points than are possible, which is why I have to do these weird workarounds. So exams are out of 75, but I give you 83 points worth of questions. So if you get a perfect score on the exam, you get 83 instead of 75. But Canvas doesn't know what to do with that, so that's, again, why the gradebook breaks down. Those are the only extra credit opportunities that I offer. Work on the regular credit first, get those 75, and then you can get the extra credit. The rest of this stuff you can really just read on your own. I think the only thing I really want to mention is anyone who has CDS accommodations, if you have the documentation filled out and filed with CDS, I have received it. If not, please do that right away so that I can get that information into Canvas. I'm going to do that probably later tomorrow night. Tonight I'm actually busy, I just realized. And then that'll all be set up so that when you take an assessment, it will modify the time by the appropriate amount. Any other accommodations you should be able to make on your own, like silent room or whatever like that. That's totally doable on your end. Finally, this class is going to be pretty intense from the last quarter that I taught this, which was winter 2021. A lot of students felt like it was easy the first little bit because it was all 140. Then we got to quantum mechanics and it was really, really, really rough. But once we got through that, the rest of the quarter was a lot smoother, and people said that like it was a really good class because they were active and engaged. My 161 was probably the most active class I had last quarter. 161 tends to be the most active class of the ones that I teach because Gen Chem students are pretty invested. Like, you guys tend to want to actually be here, as opposed to, oh, this is one step towards my degree and I just have to get it over with. And the content tends to be more interesting because we're going to talk about a lot of really cool shit. So you will get out of this class what you put in. I'm going to provide you all the videos and all the links and all the lectures and all the content that I've created. And I've created a lot of content. A lot of content. But I can't make you do the learning. So I can explain the concepts, but I can't make your brain connect the dots. So if you have questions or you're confused or you get something or you want to explain something a different way, type it in the chat. That's totally what the chat is for. There are 90 of you, so obviously, like, don't spam the chat, everybody at once. But if you have a question, don't be scared to ask it, because that's the whole point. And if you're really concerned, like, go change your username. You do not need to have your registered name shown up on the screen. I don't care. I will address you as whatever name that you choose. And we'll be good. Here's our calendar. You see that most Mondays are no class. We're going to be on Tuesdays and Wednesdays. Review sessions before exams. There's an exam at the end of week 5 and an exam at the end of week 10. So we'll have a Monday lecture those 2 weeks. We may need additional lectures on some of these days that I have marked, just in case I feel like we're falling behind, and we need a little bit more time. But otherwise, I'm not planning on using Mondays unless I absolutely have to, or the review session requires it. Lab worksheet due dates are also shown, so just be mindful of that too. So labs are shown on here. You will also get a notification in Canvas, and then the exams are just to let you mentally know, like, oh, I should be studying. An exam is coming up. All right, that is the syllabus. The last thing that I want to talk about before we take our mid lecture break is that a lot of students ask questions about, like, how do I be successful in this class? So I've put some information on the board here. The most useful feedback that I have gotten from students is that the more that they spend time before class looking over stuff, the more it makes sense and tends to gel when I go over it with you. The first time you look at anything, and this is true for anything, like the first time you ride a motorcycle, or the first time you cook rice, or the first time I'm trying to think of other skill-based things. Like maybe the first time you build something from IKEA, for example. Like it's always sketchy, right? There's always something in there that's like, this isn't super clear. What am I missing, right? And whether that is your first contact with the information is me lecturing on it, or your first contact is you reading it out of the textbook, there's going to be a degree of sandpaper in there that's rough. And the way to smooth that out is to contact that information from multiple sources and multiple angles. So if you watch my lecture and you're confused, and then you go back to the textbook may make more sense. But if you have more information, but you still have a question, you can't ask the textbook the question. If you do it in the other order, and you read the textbook and you're like, oh, okay, this mostly was okay, but this one part, then when we get to that part and I lecture about it, if you still have a question, you can ask me because it's on the air, and then I can answer it. So the order of operations is important here. Read the textbook and do something before the lecture if possible, and then go to the live lecture and ask me the questions then. Obviously, if this is past me talking to future you, that option may not be available because you can't type to me from the future, but you can still send me an email. Same thing for question number 2. If you have any questions, bring them to the lecture and then we'll talk about them as they come up, or we talk about them at the start. Do as many practice problems as you can. Now that the Discord is a thing, if you go in there, you can set up a study group. I don't know if there are voice channels in the Discord chat. I'm going to join it in just a second here once we go on a break. But if there are voice channels, like hop in one of them, talk to other people, study together, whatever works. And if you have questions, you can always invite me into the voice channel, and I can try and answer those questions for you too. Use every resource at your disposal. How much time do you need to dedicate to this class? So I give this slide just because people aren't always aware of what it means to be in a 5.5 credit course. So what this means is that a full-time student course load is 12 credits. 12 credits is roughly the equivalent of you being a worker that works in a profession for 40 hours a week. This is half that. So this is half of a course load. Almost, rounded up. So aside from the 4 hours of lecture that we have each week on Tuesday and Thursday, you also need to put in, and the data that we have acquired from other students and their performance, about 2 hours per day. So that's going to be an additional 14 hours of independent study or work. That's a lot of time. Now, depending on your aptitude for chemistry and how much preparation you have already, you may need more time than that or less time than that. This is the average. This is for a C student get a C. If you're an A student getting a C, you could probably get away with like half that. If you're an A student wanting an A, you may still not even need 18 hours. But some people will struggle and they will need more time than this. So this is just an average. The intent is to make clear that if you are taking 16 credits and you're working 40 hours a week as an essential employee, and you have to take care of your parents or your kids or whatever, and you can't go outside because of COVID, so you're going like crazy due to lack of stimuli. Like, you may have too many things going on. So please be mindful of that. The worst thing that I can see later in the quarter is I open my email and there's an email from a student that says, I got in too far over my head, I need to drop, and it's week 7 and you don't get a refund because the deadline to drop with a refund is like week 2. So, like, I hate that. It's like, man, I'm so sorry that you spent 7 weeks and like now you're just gonna get a W for it. Don't fall into that situation if you can. Make sure that you have enough time to commit to this class because it will start off pretty gradual and then, holy shit, when we hit chapter 3, we're going to be stuck in the swamp of chapter 3 for like 4 weeks. And we have to navigate through it. We have to wade through it. But it will be a slow slog and it will be intense. And that's the part where people start to just really like lose it. And unfortunately, that is right around week 6 or 7. So be mindful of that. You will need to dedicate a lot more time at that point in the quarter to maintain your grade. Okay, so we're going to be in this together for the next 10 weeks. It will go very fast, believe it or not. Blink and you'll miss it. By the end of the quarter, it will be summer, and we will have covered all of the course content, and you'll be like, man, I remember that first day where Professor West talked about, like, it's going to go so quickly, and here we are already at the end. It won't feel like that around week 6, but it will feel like that around week 9. I guarantee it. Okay, so we are now at the midpoint of the lecture. Every hour, I like to give a break because there's no reason you should have to sit here for 2 hours. So I'm going to put this on the screen. I need to get the timer out. Where's my live split? There it is. Boop. I'm going to start the 10-minute timer, and then I will start up the music again. When 10 minutes have elapsed, we will come back. So please get your water, pet your cat, use the restroom, step outside for some fresh air, whatever you need to, and we'll see you in 10. Alright, there we go. I had to set up the slides for the first chapter, and I was like, well, why not keep listening to one of the best tracks in Donkey Kong? Alright, so I saw somebody mention it in the Discord. Chapter 1's super basic. It is... Chapters 1 and 2 are mostly review from 140. Oh, here's Maya. Maya wants to say hi again. Maya, come here. Come here, Maya. Say hi to all the students. Say hi. Say hi. Yeah. They're gonna pet you. There you go. Now leave me alone. She really wants to jump on my lap, but we can't do that. I had to bend down and move her out of the way. Alright, but yeah, chapter 1, 2, and 6 are pretty straightforward. The new content is 3 and beyond. We're going to be dealing with just like categorizing matter, sig figs, how to measure anything, that sort of stuff. So pretty straightforward. So we're going to spend the first probably 4 hours or so on chapter 1. All right, so what exactly is chemistry? Why are we studying it? For the longest time, people have realized that matter and other matter will react with each other. So, for instance, if lightning strikes a tree, the tree can catch on fire, and then the substance that remains is not the same as it was before. So, something has contacted the tree, and people thought at the time, oh, the lightning was the thing that did that, or the fire was the thing that did that. So the earliest conceived notion of agents of transformation were elements, and so this is where the term element comes from. The 4 classical elements, fire, air, earth, and water, which are popular in many video games, like when you throw spells at people, they're always element based, right? So for a long time, a lot of people thought, oh, chemistry is just anything that involves these 4 things, these 4 forces of nature. What they didn't realize was that there was a 5th element, which was Lilu, and that's why the Greeks got it all wrong, right? They didn't know about her multipass. Hopefully you've seen the 5th element, or else that joke doesn't make any sense. But over the centuries that passed since prehistory and the classical era and into the Middle Ages and the Renaissance, what people started to do was they started to compile a large, vast inventory of information about stuff that worked and stuff that didn't. And so, yeah, this is where alchemy comes in. So alchemy was sort of this revolutionary idea, the quest for the Philosopher's Stone. Can we turn lead into gold? Turns out you can. It's just more expensive than the gold is worth. That's nuclear chemistry, by the way. And, like, what things did what? Can we take things that are toxic and react them with other things to make them into medicines? Or maybe even just dilute them? Or what applications do all of these things have? And this is all chemistry. And so now, today, with very advanced technology relative to what people had in these previous eras, we're probing the nature of the universe in ways that we've never explored before, so that we can understand, like, how does stuff work? Like, how does matter interact with other matter, and what causes that? Like, what are these things called electrons, and why do they buzz around in specific orbitals, and what does that have to do with anything? Like, is it important for certain elements? Yeah, that's why sodium explodes. It's specifically its electron configuration. So we've been probing the nature of matter for a very, very, very long time. And we have made our way from what seems so simple that we base video games off of it to the most complex, unimaginably like detailed discoveries to date. And the frontier of science just keeps getting pushed further and further with each new discovery. And there's always something new to learn. And so chemistry is going to be our investigation into what is matter, why does it do what it does, how does it behave in the presence of other matter. Now, a lot of people like to call chemistry the central science. I don't really like that because it seems kind of conceited, but I wouldn't deny that chemistry is sort of the foundation for a lot of things. For instance, chemistry is just applied physics, so having some understanding of physics is really useful in understanding chemistry, but it also works the other way. Like, knowing chemistry will make your physics classes a lot easier. Biology is applied chemistry. If you understand chemistry and how reactions occur, so like, how do we synthesize a carbohydrate? How do I close the ring on a aldo keto or a ketohexose or whatever to make a glucose molecule, which I can then link together with another glucose molecule to make a disaccharide or something, and then use that either in like synthesis of glycolipids or just for energy or whatever. Like, how do those reactions go? You need to understand chemistry in order to do that so that you can then get to the biology. If you're a material scientist, you need to know the specific properties of metals, like how does metallic bonding work? What does it mean when we make an alloy? How does that affect the structural integrity, the shear, and the tensile strength of materials that we would draw into rods or wires? Stuff like that. So this is all interconnected, and chemistry is sort of just like the midpoint that everything likes to pass through. So knowing enough about chemistry can really help you in all of these fields that you see on the screen. And again, that's just what I said. Physics is applied math, chemistry is applied physics, biology is applied chemistry. So knowing one helps you backtrack a little bit, and it definitely helps you go forward. And since chemistry is in the middle, that's great for us. Everything you interact with in some way is related to chemistry. So if you grab your cell phone and you power it on, an LED is showing you the information on the screen. Right now it's showing me a picture of an orc, because that's my phone backdrop. And it's also showing me a message from another chemistry faculty that just says, "So good." I don't know why Steve would send me that, but that's what it says. Where is that light coming from, though? Well, it's coming from a diode of some sort behind the screen that is vibrating at a specific frequency in terms of its electrons. The electron transitions are going up and down, and when the electrons fall, they emit light. That light is emitted and received by your eye, which your brain then interprets as a specific color. The power to do that is produced by a battery, which is the transfer of electrons from the anode to the cathode through an electrochemical circuit. Usually those circuits are powered in phones and stuff like that by a lithium-ion battery. And lithium has a very high reduction potential, so it makes it really appropriate for batteries. So your phone is also probably made out of plastic, and plastic is not a battery. Plastic is a polymer, which is made from the synthesis of a petroleum compound called an alkene with a catalyst that produces a very long continuous molecule. There's tons of places that you can find chemistry, just in everything around you, and we're going to study all sorts of different avenues and angles so that at the end of this 2-year sequence, you'll have a really strong grasp on like, oh, okay, I could tell you something about where that came from. And you could point at virtually anything and answer that question. It'll take us a while to get there, and this is the first step on that path. But I think a background in chemistry is really, really useful for helping explain the world around us. So that's our goal. We're going to look at all sorts of different things that we can do. But in order to do that, we need to start with how we do this. How do we science? And what we've decided as a civilization, we've decided that the method in which we are going to inquire about the universe and its secrets is shown on the screen here. And so this is called the scientific method. And the scientific method is basically a flowchart approach where you do experiments over and over and over again, iteratively building upon the results of the previous experiment. So how does this work? I'm going to pop up some definitions here. Let me just put those Let me put these on the screen here. But then while I draw all over the screen, is this? Yeah, okay. So you're going to have some sort of idea. And you may have some idea as to how it works, or you may have no idea at all. But what you can do is narrow it down. So if you take your idea and ask a question, then what you can do is you can devise some sort of test in order to figure out whether that idea is as you think it is. For example, maybe you think that all objects fall down when you drop them. And so, okay, how do I test this? Well, I'll drop objects, and if I can find something that doesn't fall down, then I have shown that my hypothesis was wrong. And so maybe you'll drop a bowling ball, or you'll drop a pillow, or you'll drop... I'm looking for things around my office right now. A statue of Roadhog from Overwatch. You'll drop all those things, and they'll all fall on the ground, roughly at the same speed. And then you grab a piece of paper and you drop it, and it falls really slowly. And you're like, well, that was weird. That didn't fall like the other things. So what you're doing here is you are assuming something will happen. Then you are checking to see what happens in the experiment. And then refining your result based on what you saw. And you just do this over and over and over and over and over again until you realize, oh, I've found something that breaks the pattern. Or you realize, oh, everything I am observing is consistent. We'll just cite that as a fact. So this is called the scientific method. In order to make our scientific inquiries reproducible and also meaningful to other people, we need to follow the following sort of algorithm. And the first thing that we want to do is we need to make observations and data points and collect them in a way that uses our senses in as much of an unbiased manner as possible. Excuse me. So we're going to collect observations. Now, humans, by their very nature, are not unbiased creatures. If I look at a column of water with lines on it, I might say that has 11.5 milliliters. And then you look at it and you might say independently, without hearing me say that, oh, it has 11.6. How do we get a different number? It's because we're not good at estimating. That's just not a thing that humans are good at. But what we are good at are adjectives, so we can discern something as hot versus cold, or blue versus red, or things like that. So if you make an observation and you report, oh, a blue solid appears, that's pretty reliable, and so that would be data. But when I use the word senses here, what I also want to include are not just our senses, but the senses of any sort of device. And we call those instruments. So an instrument is any mechanical or electronic device that is used to collect observations in our stead and is calibrated with a specific purpose to do so. Now, with observations, what we can then do is construct a hypothesis. Now, you do not need observations to make a hypothesis. You could just guess randomly, but you'd be basing your guess off of some sort of information based on, like, say, previous experience. So, for instance, when I go bowling and I throw the ball down the lane, I get used to how the ball curves on that specific lane. If I go to a different bowling alley, it's going to be oiled in a different way, and so my ball's going to react differently. But my first throw is going to be based off of how I would throw it at the previous bowling alley. And then, based on what it does there, I can then adjust to it. I wouldn't go to a new bowling alley and try and learn everything from scratch all over again, because I would probably just end up throwing the ball in the gutter until I figured out what was going on. So you can use previous knowledge even if it doesn't seem like it applies. And that's a good starting point. It's better than just starting completely from nothing. So how do we determine that an instrument provides accurate observations? So we have to calibrate it. And so we have to calibrate something with a known standard. For instance, when we talk about mass spectrometry, like how do you weigh an atom? That seems impossible without a reference, right? And so what we did was we actually made a reference. We chose carbon-12 as our reference, and we said, okay, 1 mole of carbon-12 weighs exactly 12 grams. That's our reference. And from there, we extrapolated everything else. Now, if that assumption is wrong, then you're right. Everything else past that is wrong. But if we define things carefully enough, then our instruments will at least be based, in fact, on our definitions. Now, that's something that we really, really, really hope doesn't come to pass. For instance, if you're working with constants, like the ideal gas constant, or we're going to learn Avogadro's number, 6.022 times 10 to the 23. If you've been using that for years, you don't want to find out that, oh, Avogadro's number was actually 5.75 times 10 to the 23. Like, that would be awful, right? However, that can happen. It's unlikely because we've done a lot of experiments to get that information. And that's sort of where this is going. So to make sure that our instruments work, we have to do experiments with the instruments, just to make sure that they are actually providing what it is that we are intending to look for. And oops, I didn't mean to do that. The way that we do that is by devising experiments. And our experiments are going to be controlled data that we acquire by setting up an experiment so we can eliminate all the other possibilities. For example, if I go back to that dropping things experiment, and I wanted to test the influence of air on the speed at which things drop, I could drop feathers in a bowling ball outside, and then I could compare that to dropping them in a giant vacuum chamber, which I show that experiment in 140. So if you want to watch that, you've probably seen if you took 140 with me. And then you would see, oh, okay, well, there's the difference. The only difference is that one situation has air and the other one doesn't. And in the no air situation, everything falls at the same velocity, which is interesting and yields data that, oh, things are slowed down because of air, not because of the properties of the objects themselves. Now, as you do this sort of cyclic building of information, you generate more and more and more and more ideas. As you go along, we end up devising sort of a repertoire of facts or observations that occur every single time we do the experiment. And so this is really important to note when we discuss scientific facts. So every time we do this experiment, in other words, it's reproducible, we get the same result. So this is crucial for science. If I do an experiment and I get a result that's like, hey, I've invented a perpetual motion device. I spin this and now it's spinning forever and it will generate an endless energy. That is only useful if somebody else can do it. If somebody else can't do it, then we call it quackery. That's not science. So this happens a lot in like very fringe fields where people suggest like, oh, this is something that you can do and this result you will get it every time. And in reality, it only happens when they do it. And so that's not science. Science requires that if I can do this and I get this observation, you must also be able to get that same observation, or else something is wrong between how we did the experiment. So something else has to be available to show that the experiment can be reproduced. And yeah, so using a second instrument or having a second person operate the instrument or sending your experiment off to another laboratory and having them reproduce the experiment, these are all very important things to do. Because there is nothing worse, and this actually happened to me in grad school, than getting a procedure from another lab, following the procedure and getting a result that doesn't quite match theirs, and you can't figure out why until you learn that, oh, their laboratory was just hotter the day that they did the experiment, so their yield was way higher, or something silly like that. That's not quite the circumstances I had an experiment for in grad school, but it is super frustrating if you end up with quackery and not an actual reproducible scientific fact. Now, if you do a bunch of experiments and you gather a bunch of facts together, you start to explain the world around you. So, by looking at different experiments that are of similar nature, you can start to compile what are known as laws. A law describes how matter behaves in a very regular way. And a great way that we use to explain how matter behaves in a very consistent way is by formulas. For example, here's a very famous formula. This says that energy is related to the amount of mass that is consumed times the speed of light squared in a given energy mass conversion reaction, such as, say, fusion. Now, why does energy turn into mass? The formula doesn't tell you. It just says that if I convert this much mass into energy, I will get this much out. It tells you nothing about why this is happening. That is the purvey of a theory. A theory tries to explain what's going on at the most deep level that we can get. And so this is really important. This is the why. This is what we're looking for. If you think of I want to say it's like a cartoon or maybe like a sitcom from like the 90s, before most of you were born, I'm sure. I want to say it was Full House, and one of the kids goes, "Why?" And then the Bob Saget, I guess, would answer the question, and then the kid goes, "Why?" And then they answer the question again, "Why?" And when you run out of ways to say why, that's when you get to the theory. So the theory is like the highest level detail explanation for something that we can come up with. And there is no why past that because we can't conceive it. Maybe someday we will when instrumentation improves or we develop a better sense of clairvoyance or, I don't know, something like that. So those are the parts of the scientific method. We're going to do experiments in a cyclic sort of way, gather information. We're going to then organize that information into a law that describes a collection of experiments. And then with more experimentation and testing, we can develop theories that explain why matter behaves as it does. Yeah, every kid does the why thing, right? I don't know if I did. Maybe I did. The other thing I want to comment about the word theory is you might hear the word theory misused a lot. Some people will say, don't worry, it's just a theory. There's one particular guy on the internet who does that. He does it's just a theory, a game theory. These people don't understand science. So if you hear somebody say, it's just a theory, don't worry about it. That is the complete opposite of what the word theory means. A theory is like the best thing that we have in terms of science. So if somebody has a theory on something, they're misusing the word unless they are like the premier forefront investigator of a particular field of science. When I say the theory of relativity, what that means is we understand everything about how light and gravity works to a very high level of detail. You don't say, "Oh, it's just a game theory." Like that's misusing the term. Oh, I do have these videos on here. I forgot about these in the 161 slides. So, all right, what I'm going to do is I'm going to show you some experiments, and we are going to watch them to try and devise the scientific facts that we can observe in these and what I show here. I'm trying to find my cursor. There it is. Okay. So let me load up experiment 1 here. I have to capture the video real quick here. And then this is going to be 2 big. That's the wrong one. That's the right one. So let me catch just the video. And then I can make it bigger. Yeah, I really did. I do this every quarter. And I have not got any complaints yet, but I expect someday. Or maybe he'll just stop saying it's just a theory and actually be scientifically consistent. All right, so here's experiment 1. Do I have audio for this? I don't have audio for this, so let's do that. I want you to observe the following scientific fact for sodium dropped in water. This can has the water in it, and the scientist has sodium in his hand. There we go. Ooh, exciting. Okay, so the scientific fact that we observe is that sodium dropped in water creates music, right? Because listen to what happens when it explodes. That's how it works, right? No. What scientific fact would you actually make for this? Well, what happened when the sodium was dropped in the water? While you consider that, let's look at experiment 2. Which, this warning is so silly.
Disgusting. Disgusting.
What are you... Did you miss? No, they're in... Didn't you hear the boom?
Good doofus.
Yeah, no, it's floaties.
The longer it takes, the farther back to get. It takes a...
Jeez!
Alright, now that you've seen 2 of these, what do they have in common with each other? So the first one was a high school teacher doing a demo in the courtyard of their high school. The second one is very highly trained professionals in the forest throwing chunks of sodium into a bucket of water. But regardless of the experiment source, what scientific fact did you observe? You can type it in the chat. Everybody hates buckets. That's a good observation. Now, while you are typing your scientific facts into the chat, I'm going to get experiment 3 going, which looks like this. Very good. It reacts with water. Was that what you observed with test number 3 here? Where we put this little chunk... I'll play it again here. Oops, I want to replay here. Yeah, it lights on fire, doesn't it? In fact, if I pause it at the right time here... There you go. That's sodium. So, we have observed a scientific fact. Sodium reacts violently with water. Now, why does it do that? Well, we can't tell by doing this experiment. All we can observe is, oh, yeah, it reacts pretty violently. There it is, right? Cool. Now, how would we get a law out of this? Well, you can't make a law out of just one experiment. You would need to make a law out of various experiments. So what we would have to do is say, okay, can I figure out, like, how matter behaves by expanding this to other elements? So maybe all elements explode when in contact with water. That'd be pretty bad if it was true. You get in the shower and then... Game over, Return of Ganon, right? So... we've already done this experiment, so what we're going to do is we're going to discover a scientific law using very specific elements. I'm going to pick these. So I'm going to pick potassium here, and we'll load this back up. This is potassium, and I'll play it again for you. And so what I want you to do when you watch this the second time, how is potassium similar to sodium? Like, what does it remind... What do they share in common, and what's different also? So what happened there? Was that close enough to say, oh, that is really similar to sodium? Or, no, that's totally different. Those are 2 different reactions. Obviously, this is sort of subjective, right? So what information can we collect as objectively as possible? And while you do that, I have to get rubidium and cesium up here, and we'll see if we can draw some conclusions. So I had to close this because I had to go digging through this guy's page. Because these links, for some reason, are incorrect. So not about. Let's see here. I want rubidium. Is this the one I want? Yeah, here we go. So now we're going to look at rubidium. Here's rubidium and water. That was it. There it goes. We're going to play that in slow motion because it has like 8-bit audio sounds and it sounds really cool. Francium dropped in water. There was a video for francium in water that was just a joke where it was somebody putting francium dishwashing detergent in their dishwasher, and then it showed a nuclear bomb going off. So that's rubidium. Let me get cesium real quick here. And so yeah, you're coming to the correct conclusion, which is alkali metals react violently with water. All right, so here's cesium. Blink and you'll miss it. Like, that's it. Let's do that one in slow motion, too. And I think it pauses, yeah, on the explosion. So that explosion took 2 frames. 1/30th of a second. Oh, you blinked. We'll have to watch it again. Hold on. There you go. It's just so cool. So, not only are alkali metals reacting violently with water, they become more and more violent as you go down the periodic table. Now, we don't know why that happens based on these experiments, but we at least observe that this seems to be happening. And so if I go back to potassium here, there's my sodium. Let me get potassium on the screen here. There we go. So let's time the speed for potassium and just see. So 1, 2, 3, 4. Okay, so it took about 4 seconds. Let's do sodium here. 1, 2, 3, 4, 5, 6. So sodium's a little slower. If I picked lithium, well, I gotta go back over here. Am I not in his... Oh, I'm not in his page there. What do you think lithium would do if you had to predict how fast lithium would go? Oops, I don't want to give you the answer here. Ah! If you had to predict how fast lithium would go, would you say faster than, or slower than, or what? And then pick an element to reference. And now that you've thought of what that is, maybe you're typing it in the chat right now, we're going to actually click on it and see what your result is. So here's lithium and water. There you go. So was that in line with your prediction? As fast as lithium? Well, that's technically correct, yes. Should be the slowest, right? Yeah, and it definitely was slow. All right. So when we differentiate between facts and laws, facts are specific to one unique experiment, but laws are a generalization over a bunch of experiments. So we can put together all sorts of information and collect it to get a law, and the law is made of scientific facts. Now, why does this happen for this specific experiment? For this experiment, we're going to discuss the answer in Unit 3 when we talk about quantum mechanics. And so what's actually happening is the elements we're looking at have one valence electron. And that one valence electron is easy enough to ionize and remove, which results in a reaction that produces energy. It's exothermic. Now, figuring out this experimental data... Oops, that's Steve messaging me again. Let me mute this. Figuring out the experiment to do to test this and then collecting the data for it is remarkably difficult to do. So, again, you can tell you-know-who to refer to this slide. Don't ever use "it's just a theory." That means that you're misunderstanding what theory means. Okay, so the last little thing that we want to do before we call it a day, we're going to finish up this section, which I think has 1 or 2 more slides after this. On occasion, I like to put problems up on the board and have you try to solve them. So what I want you to do is going through each experiment. In experiment A, one of the statements is a fact, one of the statements is a law, one of the statements is a theory. I want you to try and figure out which is the fact, which is the law, which is the theory. And then do that for experiment B also. So one of each of the 3 things in each experiment. And then type which statement is which in the chat as you get the answer. We'll go over the answers together in about 3 minutes. I'll see you in a bit. All right, let's go over the answers because I'm going to run out of time here. So, for these three statements on experiment A, the fact is going to be the one that is the specific to a individual experiment. So, looking at the first statement, mixing boiling water and cold water makes a lukewarm solution. That could be pretty specific. I could put boiling water and cold water into a beaker and do that experiment. The second statement asks about two objects in thermal contact with one another. That's not really specific enough to be a fact, right? And then this isn't a specific experiment at all. This is like some sort of explanation. So the best arrangement I would choose for this would be that this first statement would be a fact because I found a very specific condition that I could reproduce this experiment. I take boiling water, I take cold water, and I mix them together. And I have a second cat here who wants attention. I need 5 minutes. Go away. Go away. Over here, this statement could be... sorry, my cat is distracting me. Hold on. Let me just... I have this squirt bottle next to me that I have to spritz the cat with water to get him to leave me. Statement 2, you can get this conclusion by doing a series of experiments and concluding that, oh, if I take any two objects and they're different temperature, they will settle to the average temperature. So this becomes a law. In fact, this is Newton's law of cooling. And then the last explanation must be the theory because that's what's left. But it explains what heat is. Heat moves through molecules vibrating or bouncing off of each other and transferring their kinetic or potential energy. Yeah, a dry kitty is a good kitty. A wet kitty is a bad kitty, as evidenced by will not stop meowing. My cats are needy bastards. They just want to be hugged all the time. And I hug them all the time, but that's not enough. For set B, I'm going to look for the same sort of thing. I'm going to look for a very specific experiment. But I also don't want that experiment to have too much of an explanation to it because that leads into a theory. So looking here, I could say, oh, well, sodium chloride mixed with water is toxic. That could be a fact, but this explanation over here is... Oops, wow. Thanks, tablet. My tablet moved while I was drawing on it. This explanation right here is not something that you could get out of a fact. And so that right there leads us to conclude that, hey, this is probably the theory. And now we just have to differentiate which of these is more specific than the others. So I could say vegetables and fruits or a flour. Now, this should be some specific flour, most likely, but this is more specific than vegetables and fruits, because there are a lot of different vegetables and fruits out there. So I would call this one the fact, and I would call this one the law. Now, these are just example problems, and again, there is going to be some level of ambiguity here. But as you do more of these, you should be able to draw the same conclusion and get to the right answer. All right. Any questions, let me know. Let me do the last slide real quick. This is the last slide, right? Yeah, okay. All this slide is talking about is just how we are going to perceive the world. This is how you see the world before this class. You can just observe things. What we're going to have to do is we're going to have to imagine. We're going to have imagination time, guys. We're going to have to imagine how the world looks like at the microscopic level. So the microscopic domain is just, hey, how do molecules behave and interact? We have to picture what they're doing, because we can't do that with our eyes. We can't do that with a microscope. We can't do that with much of anything. We just have to perceive it with how we believe it is occurring and make a model. And so a lot of the stuff that we do in this class is going to be based on models. And those models are either going to be illustrated, which is this macroscopic domain, or they're going to be symbolic. which we're just going to write words to describe them. So as we go through Chem 161 and then into 162 and 163, your skill at this will improve. And you'll be able to visualize molecules moving around as a liquid, or you could take a water molecule and rotate it in your head, see how it lines up with other things, so on and so forth. That is something that you can develop as we go on. But that is all the time that we have today. So I got to hit a button real quick here. Where is the thing? There it is. I do want to thank everybody for coming out to the first lecture. We will have lectures every Tuesday and Wednesday. When we start to get towards lab content, I will throw lab videos up onto the website. I'm going to make little tutorials over the weekend so that those are available for us to view and just have handy to talk about the labs, and then I'll reference them. But otherwise, not much else to do other than come back to lecture tomorrow. So I will see you for that. We're going to continue chapter 1 at that time and get through as much as we can. Have a wonderful rest of your day, and I will see you tomorrow.